Hello viewers. See, in the last video, we understood what is Ohm's law, okay, and what is Ohm's law and how it will going to derived. Okay, you know the formula of Ohm's law in the last video. You know V is equals to IR. So now that is I is proportional to V. So how much current is increasing? That is based on how much you give it the voltage. We just see the setup and arrangement also, right? We connected here some kind of battery. Okay, well, the cell we're going to connect with the cell, we're going to connect the resistance. But okay, one resistance or we can call it as the rheostat to adjust the voltage. We're going to connect them, and we're going to connect one voltmeter to the parallelly to this, and we're going to measure the current. We're going to put ammeter in the circuit, and again at the down we're going to connect one switch to operate. That is what a plug key. Okay, this is what the arrangement we need to do practically to check whether Ohm's law is valid or not, whether the given device is ohmic or not. So that to check that, we're going to set up this arrangement first. And while in the rheostat, we're going to adjust the voltage. Okay, when you're going to adjust the voltage to 1 ohm, okay, when voltage is at 0, see the current is also not, it's 0 only. Okay, voltage is 0, current is 0 because they're proportional. Again, if you increase voltage to 2 volts, okay, we can here none are there, we're going to increase it. Okay, when you're going to increase the voltage to 2 ohm, you see the current flowing in the circuit. In ammeter, you're going to see the current. How much current is coming in, okay, in amperes, the current we can see voltage in volt. Okay, voltage across we're going to put 2, then we will get the current has 0.5. You can see here the 0.5 voltage. This line indicates the voltage and this line is current. Voltage is 0.2, this first point. And the second, when current voltage is 4. Okay, when voltage is 4, the current is 1. You can observe here. Okay, when voltage is 4, current will be 1. Again, voltage is 6, we increased. Current is 1.5. Like that, if you are increasing the voltage linearly, current is also increasing linearly. So this graph you will get. So join all these points. You will get the straight line. With the straight line passing through the horizon, it shows that it is a ohmic device. Okay, like that we're going to prove the Ohm's law with a given devices. Okay, I given resistance. I hope this is clear, children. After this Ohm's law, in Ohm's law we take V is equals to IR. Then what is that R? R is the resistance and resistivity. So how are you going to understand these two words, resistance and resistivity, in this slide? Let us see. See, first of all, what is the resistance? Okay, resistance means it is defined as a adherence to the flow of the current. Okay, adherence means it is opposition. We can try to move like this. Okay, opposition offered by the material to the flow of current. Okay, that is what we call it as a resistance of that material. Okay, how are you going to define the resistance? If current is flowing in this direction, the resistance is like opposing, it is pushing upwards, not allowing to go easily. Okay, that is what we call as a resistance. If a material having a low resistance, current will flow more. If a body having a high resistance to opposition to flow, that type it will have more or less current will flow through this. Okay, that is what. And the ratio of the potential difference across the current, how it is rated, R is equals to V by I. Okay, you know V is equals to what, children? It is IR. We want to find R. Remember the triangle. Okay, VR, IR, RL. So how you want to find R? This one. So V by I. V by I will come. So SI unit of volt. SI unit is volt per ampere. So how it is? You know the current, right, children? Resistance is equals to voltage. Resistance is equals to voltage by current. Voltage is volt, and current is ampere. Okay, current is ampere. So that voltage per current, volt per ampere. Okay, so that is what we call volt per ampere. That is given by new term because Ohm is invented this name. That is why we given his name only for this volt per ampere means that is Ohm. Denoted by the symbol, it is Ohm. So how volt we can remember the symbol V, and ampere current is A, we can write. Okay, like this only. We're going to use the symbol to represent a Ohm is reverse of C, and we can write like this Ohm. Okay, and the reciprocal of the resistance is called as a resistance is called conductance, that is given as C. Okay, and the SI unit of this is per ohm. Okay, we'll understand what is conductance. Resistance means opposition offered by, and how many electrons are flowing, that is given by conductance. Conductance means it is allowing, how much ratio it is allowing, how much it is not allowing. Resistance, it's allowing conductance. Okay, children. So in this main important while solving problems, you need to know the formula of resistance, V by I, represented ohm, and conductance, it is reverse of reciprocal of resistance. It is also ohm per. Okay, mho we also call as a MHO. Mho, it is OHM, ohm. Okay, children, this is what the symbol of resistance and conductance. I hope this is clear to you. Okay. See, on what factors does the resistance depend? The resistance will be depending upon the length, and resistance is depending upon area of cross section. Okay. See, what is that factors? Means if the length is more. Okay, if the wire having a more length, having more resistance. Suppose this wire and this wire. Compared to these two wires, see, the electron need to cross from this end to this end. It will take less time, so it will come faster, right? So that resistance offered by these particles is less here. So if a length is less, resistance is less. If the particle need to cover, electron is need to come here to here, because of more length, what happen? It will need to have grasped up so much of resistance. So here resistance is high and here resistance is low. So that is what, if directly proportional to length. If length is less, resistance is more. If length is more, resistance is more. And the resistance is inversely proportional to area. If the path, area means what? If the path is like this, if it is a less area like this, okay, it will obstruction, particle obstruction is less, very less path is there to move. So much of obstruction to come out particle. If area is more like this, so opposition is less, it will come easily outward. So that area is inversely proportional. If area is more, resistance is less. Okay, children. So that resistance is directly proportional to length. Length is more, resistance is more. And this resistance is inversely proportional to area. As area increases for more area objects, okay, area of cross section is more, that time resistance will be less. Okay, these are the two factors as the resistance of a material depend. And this proportionality symbol, so combine the equation 1 and equation 2, just combine and write what you will get. R is proportional to L by A. So to remove this proportionality symbol, we are going to introduce a new factor called as a rho. Okay, rho L by A, where rho is called, okay, the symbol rho is, that is called as a specific resistance of the material, or it is also called as a resistivity. Okay, this is also called as resistivity of the material, symbol rho. This resistivity depend upon the material. Does not change as length increases or area increases, does not depend. But resistance, it will be depend. Okay, resistance will be depend upon length and area. Okay, but resistivity is the nature of the material actually. Okay, that is given by rho N by A. While solving problem, this is very important. In the factor, what is the rho, what we take, what is the symbol? The rho is called, we call it as a resistivity. So resistivity represented with the rho. Resistivity means, so R is equals to actually what? Directly proportional to length and inversely proportional to area, and the constant of proportionality is taken the symbol rho. That is what resistivity. So resistivity is equals to resistance into area by length. Okay, it is depend on like this factors. It's different. If you want problems with solving, this time we're going to use this. However, what is this? When resistance is equals to resistivity means when area is 1. Okay, you take this value as a 1 and this length is also, you take it as a 1. So 1 by 1 ratio cancels, what you will get, rho is equals to R. When resistance is equals to resistor, when rho and L are 1 unity. Okay, we can take like this. So specific resistance R is also called as a resistivity. Both the symbols are same. Resistivity are also called as specific resistance. Is a resistance of a conductor of unit length and unit cross-sectional area. That is called as resistance specific. Specific means specifically we are representing 1 and 1 for area and the length. That is what we call specific resistance, and it is denoted. It is depends on the material of a conductor. Like iron will have different, copper will have different. Okay, iron. Okay. Iron, copper, if you take aluminum, all the material will have different resistivity or conductivity, denoted by the symbol rho. Okay, R, which means rho like this, and the ohm meter. Here see, resistivity is equals to our children R A by L, right? Where R is a resistance is ohm, area means it is meter square, and the length means meter. So you can cancel this 1 meter and this meter. What you will get it is ohm meter. The symbol of resistivity is ohm meter. Okay, and P, pressure is directly proportional to temperature of the conductor. Pressure it is rho, children. Resistivity is directly proportional to the conductor, the temperature of a conductor. Okay, if the temperature is more, resistivity is more. If temperature is less, resistivity is less. Okay, children. That means if more temperature, what happen? No, the particle will have more kinetic energy. That means they keep on moving. That time, any other particle need to move here. No, it will just obstructing. The obstructing means more obstructing means resistivity will be more when temperature is high. Okay, when temperature is increases, all the particles will keep on moving. They're not at rest. So when the particles are moving, that time we need to drop more, go out. That is very difficult. That is what resistivity depends. Resistivity directly proportional to temperature of a conductor, and this is also known as resistivity. I hope this is clear, children, regarding specific resistance. Okay. You can observe resistivities of different materials, like you can see all silver. Okay, different materials resistivities you can observe. So silver, copper, gold, these are all the good conductors. Okay, like conductors, we have see the resistivity is how many ohm meter? 10 to the minus 8. But you can see nickel, coal, they are good insulators actually, rubber, sulfur, quartz. So this resistivity you can observe here, it is the high. Okay, they have high resistivity, insulator will have, and conductor will have low resistivity. Okay, children, 10 power minus it is not less, so that it is only less compared to this minus 8. Okay, so it will be dependent. You can see the quartz at a very high resistivity, 10 power 70. Sulfur, okay, rubber, you can see glass, you can see. So these are insulators. Okay, and these are conductors. If resistance is low, they are called as the act like a alloyance of a current. That is means conductor. If resistance is more compared to current, that means they have more resistance. They act like an insulator. Does not allow electrons to flow because of high resistance. I hope this is clear, children. Okay. See, in the resistor for using laboratory purposes or any instrument, we are going to fix it for two types of resistors we are going to observe. One is resistors, one resistor called fixed resistors. You can observe here, no? The resistors, all this small instrument you can see in the motherboards of any your electrical appliances. There you can see the small, like this resistors you're going to observe. These are the resistors having particular band. Based on this bands of the colors, no? Different colors is there on this surface. No? They will indicate that resistance of that material, whether it is 2 ohm, 4 ohm, 5 ohm, like that. So whatever, there are fixed values. Okay, their value does not change under any physical condition. They are called as a they set for particular value only. They are called fixed resistor. And the variable resistance means the resistance can be easily changed by changing area of cross section and the length. See here, this rheostat. We're going to adjust this knob is there, no? You can adjust up to here means what happen, the length will going to increases. Are we going to adjust only this height, this much, the length is decreasing, like that we're going to increase the cross section also, and we're going to increase the length also. So by changing the variable resistance, we will going to adjust. So resistivity means what, children? It will be depend upon RL by A, right? RA by L. So depending upon area and depending upon length, so based on that we're going to vary, means resistivity is also going to vary. That means variable resistance. Okay, depends upon length and area. It will going to change this by adjusting. You can movable. Okay, we can to move this one here to here, and we're going to adjust the screws also to change the resistance. These are the two types of resistance used for laboratory purposes. See, this kind of resistors, we're going to increase their power. Suppose we take one fixed resistor, we're going to increase the power. That time we're going to connect in series, we're going to decrease, we're going to connect in parallel, like that. So we're going to take, instead of one resistor for our application, we're going to take two or more. Okay, like that we're going to connect in series or parallel. We will get the effective resistances. Okay, that will try to understand the connection or combination of two or more resistors. There are two types of resistors we're going to observe. One is series combination and the parallel combination. Okay, two combination we're going to connect the resistors. Here first try to understand what is the series combination actually. Okay, series combination is when resistors are in series. When resistors are in series, okay, when two or more resistors are connected end to end, okay, constitutive, then are said to be connected in series. End to end means this end of the resistor. So this is a resistor. We're going to use a symbol. Okay, you saw in the figure this is a resistor, but while writing symbol, we're going to write this shape of the resistor. Suppose A one end and B other end of this. This is end is connected to one more resistor, and again this end is connected to one more resistor. Like this, we will connect end to end. Okay, that is what we call as in series. Okay, when the number of resistors connected in series are joined to the terminals of a battery, how many we connected? No, that all we going to connect it to one battery. Okay, like this, whatever we're going to connect to battery. Then each resistor has a different potential differences. Potential differences changes it ends, which depends on value of a resistance. But the total potential difference across all the ends of a resistance in all the resistors in series is equal. See, what they told is that R1, let us take R1, R2, R3, all are different values. Let us say 2 ohm, 3 ohm, 4 ohm. Like that, if differences resistance are there and potential difference between these two ends is different. It is V1, it is V2, and it is V3. Like that, potential is different. But total potential that will be is equals to how much you are supplying potential. Okay, total potential is nothing but what you are supplying from the battery, that will be equal to this. But individual resistance between the potential between the each resistance will be varied, so that V1 is not equals to V2, not equals to V3, we can write not equals to V3. Okay, like this we can write. When the number of resistors are connected in series, then the same current flow through each resistor. Whatever current is coming, okay, from this positive to negative end, same current will flow from here also, here also, here also. So total current I is constant throughout the circuit. So we can write I is constant, it is not changing. That is I1 equals to I2 is equals to I3. That means through current passing through R1, R2, R3, all are same. That is equals to I. But potentials are not same in series, current is same. Clear children? This is regarding series circuit. Series means we are going to connect end to end like this. Okay. Okay, to derive the relation for the series or effective resistance, how you are going to calculate it? Let us see R1, R2, R3. Here R1, R2, R3 are the three resistors we taken, and voltage. We need to measure voltage across each one. We need to connect voltages V1, V2, V3 are all the three. Okay, this is voltage difference between R1, R2, R3. I told already it is not same. Okay, that way sum of all this is equals to what we provided, right? Each one, what is the sharing? Suppose we provided 20, means we are going to share here. Suppose we provided 15, let us take equally here 5, here 5, 5. Not like that, it's not equally divided. Based on the resistance of this node, we're going to divide maybe 6 or 5 or 7, whatever. But total, you're going to add this total, no, that will be is equals to what we provided. Okay, that is V is equals to V1 plus V2 plus V3. Okay, applying Ohm's law and for the old circuit, what you will get V is equals to IR, right? Total voltage what we are providing, that is equals to total resistance and what is the total current flowing in the circuit. Okay, applying Ohm's law for the three resistors separately. Let us imagine separately we will apply Ohm's law. What is this voltage is nothing but what is the current coming here and the resistance. So V I into R1. And here also what is the current coming and what is the potential. Current, let us take is I only because current is same through all the three circuits. So I into R2. And here what is the current is equals to R3 into R3. V3 is equals to I into R3. Like this, we're going to take the three resistors separate equations. Now, substituting 2, 3, 4 in 1. Okay, this is equation 1. Now, here we're going to substitute this. What you will get? V is equals to C in this equation. In place of V, we're going to put this one. Okay, left hand side in place of V, we're going to write IR. In V1 place, we will write IR1. In V2 place, you write IR2. In V3 place, you write IR3. Okay, like this equation, you will get substituting all this in one equation means. So R, we can write this. I is going to take common factor here, I here, all the three factor I is there. So I is going to take common factor. What you get? R1, R2, R3 you will get. Now this I and this side I we going to cancel. So what remaining now? R, that is the effective resistance, we also called RS. Okay, effective resistance in series combination is given by sum of their resistances R1 plus R2 plus R3. Right, children? So therefore we conclude that sum total of resistances in series resistance connection is equal to the sum of all the resistances. Okay, sum of all the resistances. Okay, this is what the resistors in series. Okay, children, so remember the formula. When you connect resistances in series, different two or more resistors in series, that time you will get the formula like sum of R1 plus R2 plus R3. How many you connect? That means